move to some ways you may not have thought of using Desmos on EQAO grade 9 math test. In previous videos, we showed you how to use graphing and tables. Now let's look at ways you can use algebra. So we'll dive right in and look at this first question. Which value of x makes this expression true? So again, we hope that our students can solve this algebraically, but Desmos is a great spot to check that our algebra is correct. So again, I'm going to go split screen here, and I'm going to put the equation 5x minus 1 equals 3x plus 9. And you'll notice that when you put in an equation, because there's only one value for x that is true, you get this line. And that is the value for x. And you can quickly see, just by pushing this, that the answer is 5. So all equations, because there's only one value for x, are going to produce this vertical x equals line. And we can even just confirm it by just going x equals 5. And you'll see that this green line just goes over top of it. So x is, in fact, 5. So very quickly you can put an equation, and get your answer right away. Let's look at another question. This time we're looking at equivalency. Here's an expression 4x minus 8, and we want to see which one of these it works. So I'm just going to delete those, and I put in the first one, 4x minus 8. So 4x minus 8 is our goal. That's our target. So if I go underneath here, and I try the other equations, 2 bracket 2x minus 8, I'll get a different graph. The only way this can be equivalent is if it produces the same graph. And so obviously that's not going to be one of my answers. So I'm going to turn that guy off. 5x minus bracket x plus 8. And notice that this one overlaps the graph. So I feel confident that this answer equals 4x minus 8. And so again, this is, I can check the algebra and of course see that it's minus x minus 8, so that does work. But Desmos is a great tool to check that answer. This is a question that select all, so we're going to have to try all of them, not just find 2. This third one, 2 bracket 2x plus 4, overlaps, so it looks like I'm going to select this one as an answer. And then the final one, 4x minus 3 minus x, well, it should be a 3x, so yeah. You see that's pretty close, but of course doesn't match. And so very quickly, Desmos will allow us to find the 2 that does work and check our algebra. Here's another one where it's a drag and drop in Desmos. So I've got the main one out there, so this is our target. But notice that, of course, when we graph this is going to produce a graph we really don't look at a lot of in grade 9. It produces a quadratic. Now, students should be familiar with this as a non-linear one, but they don't know anything really about quadratics. But again, we're just trying to make this match. So I've got an option of choosing like a 4x squared, and let's put a 0. So I'm just going to go and see if that works. 4x squared plus 7x is in there, and then minus 0. And I can see, just choosing a different color. By the way, if you change colors, you click and hold. That's how you get that menu to be able to change. So I can see that that one doesn't line up, so this match doesn't work. Let's just quickly change the second one. If I change this to a 10, that doesn't work. If I change it to a 5, that doesn't work. And that's because my first one of 4x probably isn't right. Let's try 12x squared. And again, a little bit of algebra will tell me that I've got a 3x times a 12x is, 3x times 4x is 12x squared. So I feel better that this one works. And look, indeed, 12x squared plus 7x minus 5 ends up being exactly the same as the one we had there. So I feel good that that's my answer. In some questions, you'll have examples like this, where the expression is given to you with y's. So just a little heads up for your students, if you were to graph this, go y9, it doesn't really help out because it's explicitly in terms of x. So you'll want to teach your students that let's use X instead of Y, and then still use our things. Again, this is a graph that is very different than what they've seen in the past, but we can now go in and go X to the power of 4 times, remember times is the star button, and in Desmos it appears as a dot instead of the X, Y to the power of 5, again, using X, not Y, and I can see that those two do line up, and so I'm going to feel confident that this is the answer I want. I can quickly check other ones. You can either type them, you can duplicate them, you can go here and duplicate a bunch if you want, or you can copy and paste. I'm going to try X to the power of 5, X to the power of 4, and, oh, sorry, this one's plus, isn't it? And just turn that guy off. And you see that that does not equal, so the second one isn't going to equal. This one is X to the power of 9 times X to the power of 1. I already know that that's 10. So again, that's not going to equal. And the last one, I'm just going to delete this and do X to the power of 10. Highlight it and go divide or use the slash, X to the power of 1, and I can see that that does map over top, so I feel good that it's going to go there. So again, educating your students that you don't always have to type in these numbers here. If we're going to Desmos, we can translate it to X, but still be able to check our answers. Of course, knowing the exponent laws, it makes this job a lot quicker, but Desmos is a tool you can check your work. And finally, since we're kind of solving equations, why not solve the one that we are almost guaranteed to see on Desmos, and that's the Pythagorean theorem, or more commonly known as the Pythagorean theorem, the side length relationship for right triangles. And so again, students will need to understand which side's the hypotenuse and how this works, and they could do it on their regular calculator, but know that you can also add it in here. So if we did a squared, let's say that's 4, so I'm going to go 4 squared plus b squared, it looks like 13 squared equals, now if I go c squared, that doesn't really help us again because we're using c, but if we use x, then if we look back, we'll actually see a graph of this function with 2 answers. And that math teachers will know that this is because it's a quadratic. There are 2 answers, but we only want the real one answer, which is right there, and it looks like 13.6 would be the answer. Anywhere on here is gonna that's gonna be 13.6. Anywhere on here is 13.6. The other one, of course, is negative, but doesn't make sense in this real life example. And so we can see though that 13.6 is my answer. And if I had a different one where a different question where I was doing this and I had the hypotenuse, let's say is 15, again, I'm not going to use a, I'm going to use x, but it does get my answer right away by using this. So just a little bit of education that when we're using Pythagoras, we'll get 2 answers. We want to find the one answer that works. So there's a couple of ways that you can use Desmos and Algebra to help with your EQAO math questions.